Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Abdul Muti, and now I will present to you about my bachelor degree project. So my project title is Stabilized Soil as Backfill for Senggarang Coastal Embankment Against Excessive Seepage. So first thing first, my supervisor is Puan Normaizati binti Abdullah, and my co-supervisor is Professor Dr. Chan Chiming. So for the introduction, I will present about the coastal embankment. So coastal embankment is a construction that was primarily developed in order to protect a section of the ocean. So embankment has a variety of usage, such as reservoir for embankment dams, seawalls for flood control, for road, for railway, and many more. So the performance requirement for embankment are mainly influenced by their planned use. So the size of embankment is various in different location in the world. Next, I will present about soil stabilization. So soil stabilization is one of the technique that have been widely used for various sectors that are related to geotechnique. So soil stabilization focus on improving shear strength of the soil and resistance to water softening by bonding the soil particle together, waterproofing the particles, or it can be a combination of between these two methods. So soil material can be stabilized with cementitious through soil stabilization like cement, lime, fly ash, bitumen, or combination of those. So the method is accomplished in two ways, that is in situ stabilization and ex situ stabilization. So it is important to know that stabilization is not an instant solution that can improve all soil properties. Next, I will present to you about my research background. So my research background is more about the seepage. So what is seepage? Seepage is flow or movement of the water from the upstream side of a dam to the downstream side of a dam via an embankment and from below the foundation or base of the dam. So this water movement takes place in a dam. So we all know that dams made on earthen embankment are most likely to have seepage issues. So if the whirlpool is present, it is possible that the dam will break, and then this has a direct influence on the stability of the embankment, and it can lead to the slope failing and the growing of poor water pressure and internal erosion, which it is also lead to piping. Next, I will present about the problem statement. For the problem statement, Senggarang Coastal Embankment, that is the site that we doing research. Senggarang Coastal Embankment, we all know is experiencing severe seepage, which it can cause the embankment can be collapsed or cause a considerable flood risk. So the issue with seepage has seriously threatened the embankment stability and safety. So particularly in the areas, if the tide comes in, it have a possibility it can be submerged. So the Senggarang Coastal Embankment is now experiencing significant seepage and overflowing issues, both of which have the potential to cause damage to the adjoining service road, to flooding of the inland side at high tide, and the impending possible collapse of the embankment. So other than that, the increase in sea level is also one of the most worrying and costly aspect, that it will threaten the safety of the area. So that is the problem statement. So for the objective, we have 3 objectives. That is, first is to examine the existing backfill properties for Senggarang Coastal Embankment in terms of functionality and their performance against seepage. For the second objective, it is to propose an effective stabilized soil backfill scheme for Senggarang Coastal Embankment to counter the seepage problem. So for the third objective is to decide the soil backfill with sustainability consideration. So next, for literature review. First is seepage. So we all know seepage is one of the most significant issues. If it is not unchecked, it will provide a significant challenge or significant damage to the dam. So seepage is a failure if we fail to control the seepage in foundation, and permeability of a dam is typically the cause of major problems such as excessive hydrostatic pressure in the upper impermeable layer in the downstream of the dam, as well as liquefaction and piping underneath the dam. So next is stabilized soil. So stabilization of soil involve the addition of stabilizing agents or binder material to soil that is already existing but is weak. So this is done in order to improve the geotechnical properties of the soil, such as its permeability, durability, compressibility and strength. So fine grain granular material are simplest to stabilize because they have a high surface area in comparison to their particle diameter. So this type of soil heat stabilization is dependent on the selection of the appropriate binder as well as quantity of binder that is applied. Next is carbon footprint. Carbon footprint is total amount of carbon dioxide and other greenhouse gas emissions throughout the course of a process or product entire life cycle, or direct and indirect emission of CO2 that are produced by an activity. So at the moment, the input-output technique and the life cycle assessment technique is the most often technique that is used to determine the carbon footprint. So next is pore water pressure. For pore water pressure, the pressure that is pore water pressure is the pressure that is exerted by the fluid phase in a porous medium such as soil or rock that is consists of a solid framework and pores that are filled or partially filled with water or another fluid. So pore water pressure can be measured in terms of isotropic normal force unit per unit area. So instead of measuring the pressure inside single hole, pore water pressure is often averaged across a sample elementary volume that contains numerous pores. In groundwater system, a water table defined as the surface that experiences zero pressure relative to the atmosphere. So for the dam that we will discuss is 3 types of dam that are related to this project. That is, first is homogenous dam. Next, the second is thin core dam. The thin core dam is a normal type of dam that, and in the middle it has the core. So the last dam is zone dam. Zone dam is at the core. There are outer core in the both sides. Next, for the literature review is Plexis 2D detail. So it has 5 detail. First is permeability. What is permeability? Permeability is the capacity of a soil to allow water to pass through, and it is known as permeability. So the seepage will be larger when the soil have higher permeability. Next is Young modulus. Young modulus is the amount of solid stiffness or resistance to elastic deformation while it is being loaded is measured by Young modulus. So this is the fundamental concept, and when the material subject to compression or extension, the material will go through an elastic deformation, and then when the load is released, it will revert back to its original shape. So next is Poisson ratio. So what is Poisson ratio? Poisson ratio is an elastic characteristic of soil, and it is defined as the ratio of lateral strain to longitudinal strain under an uniaxial stress. So if there is no lateral movement in the soil while it is loaded in an uniaxial direction, it means the Poisson ratio is very near to being equal to 0. Next is soil cohesion. For soil cohesion, the cohesion is a term that used to describe the shear strength soil. So soil cohesion is the intercept on the shear axis of the Mohr-Coulomb shear resistance lines in the stress plane that represent the shear stress effective normal stress relationship. So effective cohesion is an essential shear strength parameter that must be determined in order to assess slope stability. And lastly, for plexus 2D detail, is friction angle. So the soil friction angle is the angle of inclination with relative to the horizontal axis of the Mohr-Coulomb shear resistance lines. Next, I will present about methodology. Firstly, a controlled embankment homogeneous type has been done using clay soil only and bedrock as foundation. So the height of the embankment for our model is 3 meter. So for the next is the control embankment that have been done will be added with load 1 ton. After that, 3 types of stabilized soil with different K been used for the homogeneous soil. Next, for the thin core dam has been made using pervious soil as for the embankment and 3 types of impervious soil as the core. So for the next part, we design the zone dam. So for the zone dam, the pervious soil has been used for the material for embankment, while 2 types of semi-pervious stabilized soil are being used for outer core, and the pervious soil will be used in the inner core. So for the next methodology is for the objective 3, it is to decide the most effective stabilized soil. So the performance and effective of all soil for the embankment should be tested, and some aspects such as total displacement, pore water pressure and effective strength will be counted. So from the result, the 2 base combination of stabilized soil will be chosen to make an effective pair for the outer core and inner core of the zone dam. So next, for the expected result, we have 4 expected results. First is the project design will be present in 2 dimensions using Plexus 2D software. Next, the soil sample will go through the simulation process and be observed by examining their total displacement, pore water pressure and effective strength. Next, the expected result from objective 2 will be obtained by choosing the best dam types and soil combination from the simulation result obtained. And lastly is for objective 3, it will be obtained by calculating the carbon footprint for the soil sample. So that's all from me. Thank you.